Hello and welcome. My name is Charles Johnson, lead trainer and technical engineer at Lynxspring, and today we're going to be concluding our BQL videos. So the first video I did was a presentation on what BQL is. BQL stands for Baja Query Language. We talked about the knowledge of B formatting or Baja formatting being very useful in how you build your queries and how thought out they can be. We also talked about using Control L, which inserts the ORD. And remember, the ORD is the Object Resolution Descriptor, which is basically Niagara's version of URL. And we also talked about what a BQL query needs. Well, the first thing it needs the base order. Then it needs projection, something to what it can actually look for, what it can project. And then we need predicates, meaning where are we actually searching for this? Or what component we're searching for. Uh, so in my JACE, and I do have here an Edge 534 that I'm going to be doing like 2 queries with. But I have a folder right here, and it's labeled BQL, and I have both meters and overrides. I also have first floor, second floor VAVs because I'm going to be doing a BQL grid with how to display some of this stuff dynamically. However, first, we're going to be doing just talking about how to use projections first. And I'm going to go into my meters folder, which has the submeters folder and the sine wave ramps and some random numbers. Now, these objects here also have numeric COVs and numeric intervals underneath because we're going to be doing a BQL against a history as well. And I will show you how to do that. So the first one that I would like to do, and I just want to show you how the columns correspond with the projection field names that we use. And remember, if I'm here in my wire sheet instead of like a BQL grid, I'm going to hit Control L, which inserts the current ORD that we have. I'm going to go ahead and expand this window here. And we have our current ORD. Now we are going to do a prediction. So the first thing is we're going to do BQL :select, because that's how we start all of our BQL queries. And now we're going to choose what we call use some B formatting here, and we're going to use slot path, which literally means the path of the slot that we're in. Then we're going to do display name. Then we want to take the value of the out slot of what we're looking for. And we're going to look in anything that has a numeric point, and we're going to do from control : numeric point. So now that we have all this here, now we can replace this IP address with local, and if you wanted to save these queries, you absolutely can do that. However, again, we're going to take the local Fox S station slot /BQL /meters. So this is our base ORD right here. And then this is our projection. And then here is the predicate. So now I'm going to select OK. And now we see the slot path, display name of the numeric point, and the value of that. Well, while that's good and dandy, let's see what we can do to actually change these names to something that someone else can understand. While I'm in here, if I hit Control L, guess what? It brings up the BQL that we just did, the BQL query. So we're going to be doing a lot of this, and I recommend that if you want to change some things, you want to do it in the BQL query that you're doing. So now I'm going to use the as clause here and say slot path as, we're going to say path. And now display name as, we're going to name this display. And then the out.value, we're going to name output value. So now what we're doing, we need the as clause here. Okay, so what we're doing here is now we are giving names to the columns that we were searching for anyway in our projection. So now if I hit OK, we see now that the paths or that the projections have been aliased or the columns have been aliased with the name that we want to do. So I'd like to also show you a couple things as well. One is using the asterisk projection, one that's not used very often, and I'm going to show you why. So I'm going to go ahead and get my Control L back on. I'm going to go ahead and just move this down here for a moment. Okay, so now what I'm going to do is I'm going to go ahead and just get rid of all this right here. And now I'm going to use the asterisk projection here. And I'm going to look in my sine waves that I have here. So to find the sine wave, I need the kit control module. And so I'm going to do sine wave and hit OK. So now we can see that it's bring up the slot path, the string, the facets, the period, enabled, out, amplitude, update interval, proxy extension if there is one when there isn't, so it's null, and of course the offset. So we can bring all the components in from the sine wave that we need. Now, let's go ahead and what if we don't use a projection? What happens then? Well, let's take a look. Let's go ahead and get our Control L on again. I'm going to go ahead and expand this. And now I'm going to just say select from control numeric point. And now we see we have 14 different rows. And it's bringing up parent, frozen array, component space. I mean, a lot of stuff. So this just is returning everything that we can from anything that's considered to be a numeric point. And I know that I seem to be scrolling fast, but it's a lot of different things here. But it's bringing up every component that we have that that is common with the ramp, sine wave, and random. So what I think what I think I want to show you now is how to aggregate data. So let's go ahead and get our Control L on. And we're going to go ahead and expand this again. So I still want to use from control point or control numeric point here. But now what I would like to do is now let's go ahead and select the display name, the max from max of the out.value, and the count from the numeric control point. And let's see what it brings up here. So now what it does is that it actually, how do I want to explain this? What this one does. This actually is just going to aggregate data. Okay, so the aggregate function that we're using is grouping itself by the display name, which is what we've done. And then the column count shows how many components are within the same grouping. And then the maximum column displays the maximum value of the component within that same group. That's actually the best that I can explain that one. So that may not you may not understand a little bit there, but that is the best that I can explain it. And hopefully that's a good explanation. If I can think of a different explanation, maybe I'll re-record the video with that in there. But for now, that's what I'm going to keep. Okay, so we've gone about aggregating a little bit of data, showing how what we can do with projections or lack of projections. But now let's go with one that I think is very useful. I'm not going to be in the meters, but what I'm going to do is I'm actually going to go to my histories. And I actually want to work in the history space. More specifically, I'm going to look for my sine wave meter. And sure, this is nice to look at, but wouldn't it be nice to just display the timestamp and the value from this? Well, I can do that by doing this. I can go to my Control L, and let's go ahead and expand this. And so now what I'd like to do is now that I have my history, right? This is going to be my base ord that I want from the history space. And now I'm going to use a projection, and I'm going to do a BQL select timestamp and value from my predicate, which is my Lynxspring test meter sine wave. And now if I hit OK, now I can see the timestamp and the value of my sine wave, of everything that's been going on. So let's think of another thing that we can do in meters here. Well, one thing that I can think of that we can do to look at predicates again is this. Let's do Control L, and let's go ahead and look. We were doing a lot of work with the sine wave, but I'm wondering if we can just do something with the ramp block only. And I'd like to display the amplitude, the offset, and the period of this of my ramp blocks only. So let's go ahead, and we have our base ord. Let's go ahead and get our projections going. So BQL colon select. And now what I'm going to do is I'm going to select the name as display name, or just as name. Let's do the parent.name as the parent. Let's look at the out.value and name it current output. And then let's do amplitude as amplitude. Offset as offset. And period as period from the ramp block. Now, where can we find the ramp block? Well, we can find it in the kit control module called ramp block. And now I'm going to go ahead. I'm going to give you guys a moment to take a look at this. I know that some of you are going to pause the video to see it anyway. However, that's what it looks at. Remember, we have our base ord right here. Then we have our projection right here. It's a fairly long projection. And now we have our predicate. And I'm going to go ahead and click OK. And now it says invalid ord syntax. Now I did something here, and I'm hoping everyone can see what I did. I believe it is a spelling error. So let's see originally what it says. So invalid ord syntax. Select name, name as name, parent.name as parent. out.value as current output, amplitude as amplitude, offset as offset, period as period from kit control ramp. Let's try that again. BQL select, name, parent.name as parent, out.value as current output. I couldn't see what was wrong right away, but clearly I typed something wrong. Amplitude as amplitude, offset as offset, period as period from kit control ramp. Let's just make sure that we've got this here. So BQL select name, and I can just say as name. There's nothing wrong with that. And let's make sure. Okay, let's hit OK. All right, so clearly I just wrote something wrong the first time around. But typing it out the way I needed to type it out again worked. It looked okay, but clearly it wasn't. So yeah, so we can come up, like we can look at specific values that are within a specific block as long as we know what to do. So we know it has offset, amplitude, and period, and that's what we actually search for. So now let's go ahead and go back to our meters. And now let's talk about the just using predicates period. So here we're going to be looking at stuff for like greater than, less than, or even we're going to search for potentially modifications of periods that we're going to be doing within our blocks. Okay, so the first thing is, let's say I want to find any value that is within my meters as my sine waves or ramp blocks, anything that is greater than 75. So to show you that we can do things like this, again, Control L inserts the OR that we need. And let's go with BQL select. And then let's look at, we're going to look at just we're going to use the asterisk here, from control : numeric point, where out.value is greater than 75. Equal select where out.value. I don't think I put a space there. I did. So BQL select. Here's why. I did not do from. Yeah, I didn't put the from there. Okay, so let's get Control L. And now we do that. Okay, so now it brings up anything that was greater than 75 at the time the query was executed. This doesn't dynamically update. However, at the time it was executed, that's what we found. Now, let's go ahead and search for functions using a wildcard. Well, we're going to use the percent wildcard here. And I'm going to get my Control L on. And instead of the where out.value, let's do where name is like sine wave So now it brings up everything um, that is named light sine wave. So every sine wave object that I have that's not a part of kit control. Now I could have just searched for, I could have gone to kit control and searched for just sine wave and it would have brought it up that way. But this just shows you another way of finding my sine waves that are actually named sine waves. Okay, so now let's go ahead and change one of the sine wave amplitudes that I have at 1 minute. I'm going to set this to 15 seconds. And then I'm going to go into this one. That one's already 12. I'm going to change this one to 12 as well. Okay. So now I've changed a couple of my sine wave periods. So now let's go into my Control L. You're going to learn to love Control L when you do these kinds of things. Okay. So now let's go ahead and do a BQL select. From control numeric point where the period is less than or equal to Baha rel time $15,000. So now we can see where my meters were actually changed. And so it's just looking for the period and the rel time. Well, how did I know that that's rel time? If I go to view and go to AX slot sheet, we can see that the period is actually being read in Baha rel time. Remember, any component in the station is comprised of slots. So if you can't find it one way, absolutely go to the slot sheet of components to find out what they have and the types of properties they have in here. And that's the way I found the rel time. So now let's go ahead and, since we're in here doing predicates, let's go ahead and still in our meters, or actually in our BQL folder here, we'll just do that one. Now let's go ahead and get our Control L on. And now let's go ahead and do select, or yeah, BQL select name as point name, out as point status, and I tell you what, let's change this right now. Let's go name slot path out.value status override expiration from control point where status dot overridden is equal to true. Let's take a look at this one again. So what we're going to do is we're going to take the name, we're going to take the slot path, we're going to look at the out.value, the status, and the override expiration of any control point whose status is overridden to true, or whose status is overridden. And so we can see here that I have 2, and my override explanation currently is null. Well, why is that? Because currently, if I want to override this instead of permanent, I'll make it, let's say, 30 minutes. Override 30 minutes. And we're going to say this is emergency active for emergency active. Okay. So now I can actually see the override expiration for points that I've overridden. Now, if I wanted this in a BQL grid, what I could do is I could go ahead and just copy at least the BQL path here and get my Control C on. And now let's go ahead and go into my report and drag a BQL grid into my report service and say overridden points. And so now I can right click and go to AX property sheet and go ahead and with my BQL grid, I can actually type in this. I'll do local colon, let's see, local colon Fox S colon station colon, and now slot colon. And then my BQL. Hit save, and now go here, and now it brings up the same thing. So now if I wanted to, I could go ahead and set this to auto, set to auto, emergency auto, emergency auto, and emergency auto. Okay. So now that I've done that, let me go and hop into my air handler controller real quick. And let's go ahead and look for 2 things here. Remember, in order to do a BQL grid, you need to have the report service module in your Jace or Edge controller or Niagara controller. So make sure that you do have them in here, but I had set them up ahead of time. So I'm going to bring in a BQL grid, and now I'm going to say points in alarm. Okay. So now, if I go ahead and go to my property sheet, and now I do the local colon Fox colon station colon. If you hear the thunder, I apologize. It is it's definitely storming here where I live. Let's see here, station colon slot colon should be okay there. Now let's do BQL colon select, and we're going to do name as point name, out as point status, from control colon control point, where status dot alarm is equal to true. Let's go ahead and see what we have here. Okay, so we have things that are in alarm. And now let's go ahead and duplicate and we're going to name it points in fault. And instead of saying alarm status.alarmed, we'll do status.fault. And now, right now, they look the same. And inherently they are. However, I'm going to go ahead and start. I'm going to go ahead and override my fan here to on or to active. And the reason why I'm going to override it to active, I go to my wire sheet, I now have an alarm here. So now when I go to point an alarm, we now see that my fan is in alarm. And my faults only show my points in fault. So we see the difference between the two. Okay, so now we're going to go do a few with the having clause and the order by, and then I'm going to show one nifty grid that you can do that will dynamically update its components, especially if you were to add more pieces of equipment. So let's go back to our meters here because we've been doing this quite a bit. And let's get our control L on. Ooh, let me accidentally hit too many buttons here. We'll just go back here. And again, control L and expand this. So now let's go ahead and go BQL select. And now we're going to say display name. And we're going to take the sum of the out.value from the control numeric point having sum of out.value greater than 50. So what this is that it is taking the sum of the values of the control of the numeric of my sine waves and my ramp blocks, and it is taking anything that's greater than 50 and displaying it. So now that we've done the greater than now, let's go ahead and change this. Ooh, control L. So now let's go ahead and take a look at the out dot value, and we're going to take the sum out now. And actually, I guess I should have done the slot path. No, I can do slot path here now. So we'll do slot path, display name, out dot value from control numeric point. And now we're going to say order by out dot value DESC. So ASC is ascending, DESC is descending. So now what it does is actually taking all my values and showing them in descending order. I'm going to do one more of these. And now what I'm going to do is that I'm going to have it go by descending parent.name first, and then the out.value. So if I do control L and do the same thing here, instead of having the out.value descending, let's go order by parent.name first. Now let's see what it actually changes here. You see now it's gone by descending order first of the parent.name. Okay, now that we've had our fun with meters, I showed you that I have floors that have a bunch of VABs. So let's go ahead and create a BQL grid here. And I'm going to name this first floor. Now, I could do all of them, but that's 100 VAVs, and I don't really want to do that. I only want to show the ones on the first floor. Okay. So I'm going to go ahead and go to my property sheet. And I'm not actually going to build this out by typing. I'm actually going to use the BQL query builder here because we haven't done a lot of it. But remember, we're going to use this here to find where we're going to do our ORD. And remember, this is going to be the type of predicate. So whenever you change anything here from the component to something else, your columns are going to reset. So if you're going to do this, go ahead and do it once. I'm going to search for my first floor only. And the first thing I want to show you here is where name is equal to space temp. And let's see what it does here first. So right now, it can't hyperlink. Why? Because we need to specify some columns. So that's one thing that's really important. So now let's go ahead back to our AX property sheet. And now let's go ahead and say, let's look at parent.name as name. And then let's look at the out.value of the space temp. And hit save. And now let's look at this. So now we see that we have our VAVs and our space temps. Well, that's okay. But let's say we want to add more to this grid. Well, this is where it's going to take a little bit of extra thinking. And it kind of has to deal with the parent.name. So what we have to do is we have to search for the parent of the object that we're looking for. Not wire sheet. Let's go to the AX property sheet. Okay. So now let's go and add some extra columns here. I don't know how many, but we're going to start with this first. Okay. So if I try to go and say damper, let's go fan command dot out dot value equals fan command. We're going to look at damper command value as damper position num heat stage. We're going to say out.value as number of stages of heat. Or just say heat stages. And then we're going to say actflow.out.value as airflow. And we'll go ahead and get rid of the rest of these. Now, this is not going to return what you think it is. So I'm going to hit OK, hit save, and now let's look at the query. We have a bunch of stuff here, and it shows that it's not right. Well, command dot out dot value is correct. However, we need to find where it actually is. So we need to come up with the correct query and looking up for the parent. So now if I go back to the property sheet and go here, and if I go parent dot fan command dot out, and of course fan command, and then do parent as damper command. Parent heat stages. Actual flow. And now I go ahead and hit save. Now let's see what it brings up. Now it finds everything that I have here. Therefore, we always need to find the parent of whatever points we have, even though the space temp is correct. So pretty much what this query did is that, okay, it looked for name equals space temp. Once it found that to be true, now we want the parent dot name, so the name of the parent that this is in, and then the out dot value of the space temp. Cool. Well, now we are looking for these values here, but the only way to do that is to actually get it from the parent itself. So we need to find the parent that the fan command is in, and then take the value of the out slot of that particular fan, or of that particular component. I know that one seemed a little bit tough. However, what if I were to, I've got a bunch of them here, but I'm just going to go ahead and duplicate this. And now what if I refresh my slot here? So if I refresh my screen, you can see now that since I've added it, well, guess what? It now shows that I've added a device here. And of course, if I take away the device and I refresh my screen, now it goes away. So that's a really useful kind of tool. And because I'm creating a Baja query using a BQL grid instead of just I'm looking at a component and not a folder. So if I actually looked at the folder rather than the component, none of this, it would only return true at the time the query happened, unless I have some kind of subscription to it, such as a history. And then whenever the history polled, it would do it. So the BQL query inherently doesn't have a dibs poll. It needs to find a way to update the point. And that's all I have for you today on BQL queries. I really hope that you learned something from this, and I'll see you on the next one.